Okay, so permutations of digits is similar to permutations of letters that we did yesterday. Um, but largely the questions will be solved by putting dashes and then filling in the choices for those dashes. Now, there are some things to be careful about, and I would want you to see this first example closely so that you understand what is going on. This question says a four-digit number is formed by using four of the seven digits 1, 3, 4, 5, 7, 8, and 9. No digit can be used more than once in any number. Find how many different four-digit numbers can be formed if there are no restrictions. So I put in four dashes and I say that I need to form a four-digit number. Now I think of the choices that I have. There are seven numbers available. So any of those seven numbers could fit in here in the first dash. Okay, now writing 7 below this does not mean that this dash has been filled with the number 7. This just means that there are 7 choices because there are 7 numbers available. Then if I filled in one number and I cannot repeat the number, I have 6 more choices, then 5 choices, and then lastly 4 choices. This should give me a total of 7 6 into 5 into 4 gives me a total of 840. Remember that there are other various ways of doing it. Some of you may have seen this before with NPR, or you could have done it with NCR. This I feel is the easiest way for me to explain, therefore I'm using this method. Part 2 says that the number is less than 4,000. Now, when the number is less than 4,000, what strikes me immediately is that there's a restriction on this first digit, the first dash that I have, such that only the numbers 1 and 3 can appear on this position. Other numbers cannot appear on this position because the number has to be less than 4,000. So therefore I conclude that there are only two choices for this dash. Either you can write a 1 or you can write a 3. You have a total of 7 numbers available. One of those numbers fits onto this first dash. So I have 6 more choices available for the second dash, then 5, and then 4 since there was no other restriction, or the only restriction was that the number had to be less than 4,000. 240. Okay. Then part 3. Part 3 says that the number is even and less than 4,000. Now there are two sets of restriction. The first restriction is that I could have a 1 or a 3 here, and the other restriction is that I could have a 4 or an 8. These restrictions are not overlapping, so I can start to fill in my choices. I have two choices here, and I have two choices here. Always fill in the restrictions first and then see what numbers remain. If I had a total of 7 digits, I have filled in one of the numbers fits in into the first position and one of the numbers fits in into the last position. I have a total of 5 numbers remaining out of 7, and then I have 4 remaining out of 7. That gives me a total of 80. That is the correct answer. Okay, so this next question is again similar to what we did before. Let's see what the difference is. It says a four-digit number is formed by using four of the seven digits 2, 3, 4, 5, 6, 7, and 8. The numbers have changed. No digit can be used more than once in any number. Find how many different four-digit numbers can be formed if there are no restrictions. So again, this is similar to what we did earlier. I put in 4 dashes and I say that there are 7 choices for the first one, then 6, and then 5, and then 4, and I get a total of 840. This is exactly same uh, from the previous question. The second says that the number is even. Okay, so there's no restriction on the first dash that I have, but there's a restriction on the last one. What is that restriction? That either I can have a 2 or a 4 or a 6 or an 8 on this last dash, which means that I have 4 choices for this last number that I have. Okay, the other dashes have no restriction. If I had a total of 7 numbers and I filled in one dash, that means I have 6 numbers remaining. Any of those 6 numbers could appear here, then 5 of those could appear here, and then 4 of those could appear here. And I get a total of 480. This is a simple. Okay. Calculate the number of different six-digit numbers which can be found using the digits 0, 1, 2, 3, 4, and 5 without repetition, and assuming that a number cannot begin with 0. Okay, so what I have is 6-digit number, and I have 6 digits available, so I put in 6 dashes. The only restriction that I have is that the first number cannot have 0, so it can have the numbers 1, 2, 3, 4, and 5. So there are 5 choices. If I had a total of 6 numbers and one of them got filled into the first dash, I have 5 remaining numbers, and then 4, and then 3, and then 2, and then 1, so that I get a total of 600. 1, 2, 4, 4, 6, 8, 7 can be rearranged to give many 7 different 7-digit numbers. How many 7-digit numbers are even? Okay, so I'm just counting the even numbers. Okay, so an even is determined by this last dash, so that I could have 2, 4, 4, 4, 6, and 8. So I have 5 choices for this last one. Whatever number is chosen, it results in one less number available here. So I write down 6, 5, 4, 3, 2, and 1. But since the digit 4 was repeated, I have to divide this by 2 factorial, and this gives me a total of 1800. Numbers between 20,000 and 30,000 can be formed using 5 different digits from the digits 1, 2, 4, 6, 7, and 8. So I have 6 digits available, and I need to form a 5-digit number such that it is between 20,000 and 30,000. Um, so one obvious thing in this question is that the number must start with a 2 if it is to remain between 20,000 and 30,000. Okay, so there is only one choice for this first digit that I have. I had a total of 6 numbers. Any of those remaining 5 numbers could appear here, then here, 4, 3, and 2. That gives me a total of 120. We learned in the last lecture that whenever something gets fixed, it's written on top of the dash. says that six cards are numbered 1, 2, 3, 4, 5, and 6 are randomly arranged in a straight line. Find the probability that the cards numbered 4 and 5 are not next to each other. Whenever the question is on probability, remember that the denominator is without restrictions, all possibilities without restrictions. So that gives me simply 6 factorial, since there are 6 numbers. For the numerator, let's try to compute. What I need to do is I need to separate the 4 and 5. So in the last lecture, where we were separating vowels in one of the questions, we learned that if we want to separate something, what we do is we first try to settle down the numbers that have no restriction on them. So there, apart from 4 and 5, there are 4 other numbers 1, 2, 3, and 6 that can be arranged. Okay, 4 and 5 can then either settle at here, 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 and here. So there are 5 different positions where 4 and 5 could then appear. Let's first talk about the dashes, since there are 4 other numbers that can fit onto those dashes. So I'll say 4 into 3 into 2 into 1. Now, since the two numbers 4 and 5 can fit onto any of these green arrows, there are 5 different choices that these two numbers could settle on. And then the numbers could arrange themselves so that you get 2 factorial. The numbers could shuffle around, so that's, for example, 4 appears here and 5 appears here, or 5 appears here and 4 appears here. And similarly, I could keep changing these positions and then settle down on where 4 and 5 could be. So I get the numerator to be 480. So the probability will be 480 divided by 6 factorial, which gives me 2 over 3. Okay, so I decided the denominator first, and for the numerator, what I've done is I've developed a technique for separating the numbers. How do you separate the numbers? You first put down the numbers that have no restrictions and shuffle them around. Then you point arrows as to where the numbers with restrictions could appear because they wanted to be not next to each other. I have 5 different positions where they are not next to each other, and I have to pick out 2 positions from there. Then arrange the numbers 1, 3, 4, 5, 7, 8, and 9. If all 7 digits are used, the odd digits are all together and no digits are repeated. Okay, so I put in 7 dashes for the first part, and I want to put together all the odd numbers. So 1, 3, 5, and 7, and 9 are all odd numbers. So I put in a box on 5 of these numbers, and I say that these are all odd. So again, this is the same idea that we did before. There are 2 dashes in one big box, so that means 3 factorial. And then you shuffle inside the box, which is 5 factorial. So I get 3 factorial into 5 factorial. That gives me 720. Part 2. The numbers made are even numbers between 3000 and 5000. So I'm talking about 4-digit numbers. And the restrictions that I have are the numbers need to be between 3000 and 5000. That means either 3 or 4 could appear here. And the numbers must also be even, so that this last number could either be 4 or 8. Now again, this is a case of overlapping restrictions. When I have overlapping restrictions, I must fix one of these numbers. So what I do is I first fix a 3, and the numbers left at the end are 4 and 8. So I have two choices for this last dash, one choice for this one. I have a total of 7 different digits. I have filled in two numbers. I'm left with 5 and I'm left with 4 here. So I get a total of 40. Then I must also fix a 4 here. If I fix a 4 here, the only number that can appear on this last digit is 8. So I have one choice for this last one choice for this first one, 5 choices here and 4 choices here. I get a total of 20. Together they make a total of 60. For this last part, the numbers made are multiples of 5 which are less than 1000 and the digits can be repeated. So when I talk about numbers that are less than 1000, they could either be one-digit numbers or two-digit numbers or three-digit numbers. When I'm talking about a one-digit number and I want it to be a multiple of 5, there's only one choice that could land up, and that is that you have 5 as a number, and therefore there's only one possible one-digit multiple of 5. When I talk about two-digit multiples of 5, I have two digits, and I will write 5 at the end because it needs to be a multiple of 5. Now, since repetition is allowed, any of the 7 digits could appear here. Why? Because the number isn't reduced, as I could repeat the numbers. So I have 7 different two-digit numbers that are multiples of 5. When I talk about three-digit numbers, I have 5 at the end, and then 7 into 7 into 1. Why? Because repetition is allowed. When I add all of these up, I get a total of 57.